Welcome to clickmyproject.com. Let's discuss about the product. Our product is Input Vector Monitoring Concurrent BIST architecture using SRAM cells. Input Vector Monitoring Concurrent BIST in self-test, that is called BIST schemes, perform testing during the normal operation of the circuit without imposing a need to set the circuit offline to perform the test. These schemes are evaluated based on the hardware overhead and the concurrent test latency, that is CTL, that is the time required for the test to complete, whereas the circuit operates normally. In this brief, we present a novel input vector monitoring concurrent BIST scheme, which is based on the idea of monitoring a set called window of vectors reaching the circuit inputs during normal operations, and the use of static RAM like structure to store the relative locations of the vectors that reach the circuit inputs in the examined window. The proposed scheme is shown to perform significantly better than previously proposed schemes with respect to the hardware overhead and CTL trade-off. BIST techniques constitute a class of schemes that provide the capability of performing at speed testing with high fault coverage, whereas simultaneously the reliance on external testing equipment. Hence, they constitute an attractive solution to problem of testing VLSI devices. BIST techniques are typically classified into offline and online. Offline architectures operate in either normal mode or test mode. During test mode, the input generated by the test generator module are applied to the input of the circuit under test, that is CUT, and the responses are captured into the response verifier. Therefore, to perform the test, the normal operation of CUT is stalled and consequently the performance of the system in which the circuit is included is degraded. Input vector monitoring concurrent BIST techniques have been proposed to avoid this performance degradation. These architectures test the CUT concurrently with its normal operation by exploiting the input vectors appearing to the input of CUT. If the incoming vector belongs to a set called active test set, the RV is enabled to capture the CUT response. Here, this diagram shows the system flow of our proposed system. In our system, input is always given as bits. That means, in our system we are giving input bits, that is called zeros and ones, as an input to the CMOS design. So, we have designed that BIST controller, BIST design, using Xilinx VHDL code. So, finally, by the simulation methods, we are obtaining from designed Verilog based circuits, we are obtaining CTL performance, and the test result shows our results provides better than the previous methodologies. Let's see the demonstration of our product. So this panel is the Xilinx main panel. So because we have designed our methodology using VHDL coding methodologies. So these are the current library shows what are the files included in our design. This is the process panel, and then here it shows console, errors, warning, and find and place options. So this here that we can see the performance synthesis reports. So we have to select the main module. So as per our system, this SISR is our main model. We have included inside that model generator and analyzer and FCC, that is fault circuit, to identify the synthesis result. We have used an example fault circuit. So we have to synthesis and identify whether it is a fault circuit or a correct circuit using this example circuit. Here the generator is used using maximum length LFSR. Here analyzer is a signature register, that is a memory element. Generator consists of maximum length LFSR. So this is our main module. I am selecting the main module to synthesis. Here I have to select simulate behavior model. As per our coding methodology, we have designed based on this behavior model using VHDL coding methodology. Hence we are using simulate behavior model. After double clicking that, it will process. You can see what are the processes are happening and what are the console is doing, and whether if there are any warnings and errors means we can identify from here. So finally you can see process simulator completed successfully. So after completed that simulation, you will get an iSim panel. Here we have to synthesis and simulate the result. So we have to change the values as input. As we told, we have to give here as input in binaries. So I am inserting the values as binary values. Binary values should consist zeros and ones. Here I indicates input panels, O indicates output panels. So randomly I am changing the variables. Again I am changing the clock to 1 and 0. So while I am changing randomly, I can see the LFSR output comes and signature output. You can see every bits are obtained as output. So these are the timing diagram of our proposed methodology BIST architecture. Thank you.